Action.
Hi everyone, so for today's lesson we're going to be learning about atoms and chemical symbols. Before we start, have you ever wondered what the pencil you're writing with, the paper you're writing on, or what you are made of? Today is what we're going to learn about. So after today's lesson, you will be able to understand what an atom is and what the parts of the atom are. We're going to run through the experiments that scientists used to discover these parts, so you'll understand how they discovered these parts. And then you'll also be able to represent elements using chemical symbols, and you'll also learn how to read a chemical symbol as well. This is just a fun little fact. Dmitri was the scientist who published the periodic table, and he arranged all the known elements at the time in order by atomic mass, which we'll learn about later in this lesson. And he left gaps for the elements that hadn't been discovered yet, and he was able to accurately predict some of their characteristics. So this is an atom. This is a very simplified model of an atom. But so each element, a different element, is going to have the same parts that every atom has, but they're going to have different numbers of each. So just keep that in mind. So in the center of the atom, we have the nucleus, and that's going to have positively charged protons and neutral neutrons. And so this nucleus overall is going to be positively charged. And then circling the nucleus, you have electrons in the electron clouds, and those are negatively charged. How did we know this? How did we discover this? These two scientists, J.J. Thomson and Ernest Rutherford, helped us discover the parts of the atom. So J.J. Thomson, he performed experiments with a cathode ray tube, which helped discover electrons. And then Ernest Rutherford used a gold foil experiment to prove evidence of a positively charged nucleus. So this is the cathode ray tube experiment. So basically, he used a light source and shone it through a magnetic field. And in order for the light to bend towards the positively charged, there had to be negatively charged particles in the atom. So that's how we were able to discover electrons, because it bent towards the positively charged part of the magnetic field. And then this is the gold foil experiment. So they used a light source that had a flow of alpha particles, which are positively charged, and some of them were able to go through the gold foil, which showed evidence that there was empty space between the nucleus and the electron cloud. And then some of them also ricocheted off, meaning they clashed into that positively charged nucleus, and those the same charges are going to repel, and they bounce right off of each other. So now we're going to talk about chemical symbols. So the importance of a chemical symbol. They help provide standardized way of representing elements, so it just makes it easier to communicate information with everyone, all the scientists. And then it also creates an easier way to name compounds as well. They offer a concise and simple way to represent elements and chemical equations, eliminating the need to spell each element's name out. A super quick quiz, class. Why are chemical symbols important in chemistry? A, they standardize element representation, aiding communication. B, they show how compounds react, eliminating the need to write chemical equations. Or C, they explain how each compound was discovered. What do we think, class?
A.
All right, let's check your answer. It is correct. So here's the periodic table with all of our chemical symbols for all of our elements. There are 118 elements listed on the periodic table in a very specific order. There is a very specific way to read each unique chemical symbol, and it tells us how many protons, neutrons, and electrons each element has. Chemical symbols. So these are the shorthand way to represent elements in chemistry. These cannot be broken down into smaller pieces. It is this and this alone. So each symbol is made up of 1 or 2 letters, and these letters are always in big bolded in the center of the chemical symbol. So on top here, usually on the top or in the corner somewhere, is always going to be what is called the atomic number. And that is going to show the number of protons. And the number of protons is always going to equal the number of electrons. So sodium has 11 protons and 11 electrons. And then this is the atomic mass, which is the total weight of the nucleus. So we know that there's 11 protons, so we can subtract that from here, and that'll give us around 11 neutrons. So for the most part, the number of protons also equals the number of neutrons, but sometimes it doesn't. So you always will subtract the number of protons from this to get the number of neutrons in the nucleus. All right, we have a little, for our final activity, we have a little symbol scramble. How many elements can you name, class? What elements can you recognize just by their symbols?
3.
Which ones do you know?
Number 1, gold.
Mm-hmm.
The Ca, calcium.
Yeah.
And then zinc.
Good job. So yeah, this is just a fun little activity. Usually in most periodic tables it says like the chemical symbol, and then it'll say carbon down here along with the atomic mass. But yeah, some scientists have them memorized, some don't. But yeah. All right, that is all for today's lesson. Thanks, guys.